Uh, this is a worksheet that has about 7 problems on it, or 6 problems on it, on Newton's second law. And I'm going to just introduce it and talk about the first, problem. And you're going to do the remaining problems, okay? So first of all, just to remind you about from yesterday, Newton's second law is force, the net force is equal to the mass times the acceleration of the object, okay? And so this ties into what we've been talking about over the last few days, and that forces cause masses or object with mass m to accelerate, okay? Forces, net forces, unbalanced forces cause masses, objects to accelerate, okay? And you can also notice by looking at this equation that the greater the force, if you have a larger force, obviously, right? And if you have the same mass, then your acceleration has to be greater, right? Okay, so your acceleration is directly related to the force. If the object is of the same mass, if the mass doesn't change, then the acceleration is directly related to the force applied. Okay, the greater the force, the greater the acceleration. Okay, so that's Newton's second law, which is probably one of the most, probably most important laws in all of physics. Okay, aside from Einstein's E equals mc squared law. Okay, this is a very important law. So, okay, we're going to use this during the year. So let's take this step by step, talk about it. We're going to use the kind of approach we've been using all along to do the problem solving in the class, which is the guess method. We're going to identify the givens. We're going to identify the unknown. We're going to identify what equation we're going to use to do the problem. We're going to substitute, simplify, and solve. Okay? So first off, let's take a look at let's read the problem and then go from there. So we have a net external force, that's F net. This is going to be F net, right? On a propeller of a model airplane. And this kilogram, 3.2 kilograms, whenever you see kilograms, you've got to think of mass, right? Kilogram is a unit of mass. So kilogram, I'm going to mention that down here. Kilogram is a unit of mass. Okay, it's a unit of mass. Okay, so this is the mass of the airplane. It's a model airplane, and the net external force applied on the propeller of the model airplane is 7 newtons forward. So this is the magnitude. Okay, and this is the direction. Okay, and then it says, what is the acceleration of the airplane? Well, this isn't all that complicated a problem, is it? So first of all, what's given? Well, we know that the net external force on this airplane is equal to 7.0 newtons forward. And we know the mass of the airplane, m, okay, is equal to 3.2 kilograms. Okay, and so those are the two givens. What are we trying to find? What's our unknown? Well, it's acceleration. What is the acceleration of the airplane? A. What is that? Okay, so what are we going to use what formula are we going to use? Well, look at what we have here, F, M, and A. So that's Newton's second law. So we can go F net equals M times A, and F net is equal to 7.0 newtons. I'm going to leave off the units. Just keep in mind that if I use newtons for the forces and I use kilograms for the mass, the acceleration is going to be in m meters per second squared, okay, automatically. Okay, so if I put in kilograms here for the mass, 3.2, okay. And then what is the acceleration? A, okay. One thing I didn't do on this that I should have done earlier, I'll do it now, is that I haven't drawn a free body diagram. I'll go ahead and do that. So we have the propeller of a model airplane, and the airplane has a mass. And the mass of that airplane, M, is 3.2 kilograms. And there is there is a net external force. So it's not applied, it's F net. The F net is equal to 7.0 newtons. So the sum of all the forces, the F net, the sum or total of all the forces acting on this propeller of this airplane is 7 newtons, okay? And that's forward, so that's going to be positive, right? And then the mass is 3.2 kilograms. That's the mass of the airplane. So that would be what the free body diagram would look like. If you did a compass, it would look like this: forward, positive, and backward, negative. I kind of backed up and did that. So let's go back and solve the problem. We know the F net is 7. We know the mass is 3.2. We know the acceleration is A. So to get A, we want to get A by itself. It's pretty straightforward. We're going to divide 3.2 on both sides of this equation. This goes out here. It's 7 divided by 3.2. Well, so the acceleration is going to be 2.2 meters per second squared, and it's going to be forward. Okay, forward. And that's going to equal the acceleration. And I'm going to put that in a box because that's the answer. Okay, it's 2.2 meters per second squared forward. Now, there's something interesting here. The force is forward. It's positive. Okay, the force is forward. It's positive. The acceleration is in the same direction as the force. The same direction. It's also positive. It's also forward. So whenever you have a force acting forward, if the force acts in a forward direction, the body is going to accelerate forward. It's not going to accelerate backward. Okay? The acceleration is in the same direction as the force. Okay, so if the force is backwards, the acceleration will be backwards. Okay, and vice versa. Okay? Okay, so you're going to do the rest of these problems. Use this as kind of a template for how to do them, and go from here.